So we know that when we have a chemical reaction, we have to make it balanced so that we have the same amount of each element on both sides, and we do that by adding these coefficients here. But when we have a balanced reaction, that's actually telling us some really important information. So when we have a balanced reaction, those coefficients are actually referring to the number of moles of that substance that would take place in this reaction. So one way to say this in words is that 2 moles of H2 react with 1 mole of O2 in order to produce 2 moles of H2O. So basically what that's telling us is if we want to make 2 moles of H2O, that's how much H2O we want, we would need 2 moles of H2 and 1 mole of O2. We actually have a special name for this relationship called the mole ratio. So the mole ratio is a conversion factor between the number of moles of different substances in a reaction. Since it is a conversion factor, we can use it in calculations. Let's say we wanted to know the mole ratio of H2 to H2O. When we write a ratio or any kind of conversion factor, we usually write it in the form of a fraction. And since it's the ratio of H2 to H2O, we're going to have the H2 on top and the H2O on the bottom. So these coefficients are telling us the number of moles. So we know in this balanced reaction, we have 2 moles of H2 and 2 moles of H2O. So that is the conversion factor that you can use in a calculation, and they can switch so that the other one's on top if that's what you need. Another example is if we wanted the mole ratio of O2 to H2O. Well, in our balanced reaction, we only have 1 mole of O2 for every 2 moles of H2O. In both of these examples, we're looking at a reactant and a product, but it doesn't always have to be that way either. We can also look at the ratio of just the reactants or just the products. So if we want the ratio of if we want the ratio of H2 to O2, then it would be 2 moles of H2 to 1 mole of O2. Let's look at how we might actually perform a calculation with this. So we have a balanced reaction, and the question says how many moles of NH3 would be needed to produce 7.5 moles of N2. We're going to set up a T-chart and always start by putting our given in the first spot. So my given is 7.5 moles of N2. We do need to get into the habit of writing out the actual substance. Once we have our given, we can fill in our mole ratio as our conversion factor. And as always, when we do T-charts, we need to make sure we cancel our units. So whatever substance we're starting with is the one that needs to go on the bottom. So for my mole ratio, I need to have moles of N2 on the bottom. That's when I'm going to look at my chemical reaction, find N2, and whatever coefficient I have in front is going to go in that spot on the T-chart. In this case, we don't have one, but remember that if there's no coefficient there, it's going to mean that the coefficient is 1. So on the bottom, I'm going to have 1 mole of N2. On the top is always what we're trying to find, and in this case it wants to know how many moles of NH3. So my top units are going to be moles of NH3, and again I'm going to get my number from the balanced chemical reaction. NH3 is right here and the coefficient is 2. So that means our mole ratio is going to be 2 moles of NH3 to 1 mole of N2. Always going to show that those units cancel and we're left with moles of NH3. So to find my answer, I'm going to multiply the numbers on the top, divide by the number on the bottom. So I have 7.5 times 2 divided by 1. That gives me an answer of 15, and my units are moles of NH3. Let's do one more example with this same reaction. This one says how many moles of H2 would be produced from 5 moles of NH3. Start by identifying my given. We're going to put it right there with the unit and the substance. The units I'm starting with are going to go in the bottom, and to figure out what number goes there, I use the coefficient from the chemical formula. Figure out what substance is going to go in top. It's whatever we're trying to find. The question asks how many moles of H2. And find the coefficient from the chemical formula for H2. In this case, it's 3. Always show that those units cancel. And we're going to multiply across the top, divide by the bottom. 5 times 3, 15, divided by 2 gives me 7.5 moles of H2.